Hi dear students. Okay, so we are going to start our second part of the revision, that is reaction mechanism. I hope all of you have watched our last class video. Okay, so myself Riyaz Ahmed from Brainiacs Classes. So those students who are watching it for the first time, please go to Brainiacs YouTube channel, go to the playlist. There you can see Brainiacs BIRV, Brainiacs Intermediate Revision in the playlist. You can see all the videos that we have given out until now. Okay, so I hope you are understanding, and if you have any doubts, feel free to put it in the comment box. Okay, so let's start. So we were doing assertion and reason question in the last class. So again, for those students who are watching it for the first time, I am giving an introduction. So very simple. In an assertion and reason, we will get an assertion and a reason. Okay, so if both assertion and reason are true, they are individually true statements, and if you feel the reason is the correct explanation for the assertion, then we can say option A would be the correct answer. And the option B, when you will choose, we understood both assertion and reason are individually true statements. But when we are analyzing, we understood that reason is not a correct explanation for the assertion. Assertion is always a statement that will be giving out doubts like why it is like that. So if the reason is not answering your why question, I can say reason is not the correct explanation for the assertion. So in that case, we say the answer would be B. And the third one is assertion is a true statement, but reason itself is that statement itself is a false statement, that is wrong. Okay, and D means both assertion statement is wrong and reason statement is also wrong. Okay, so let's start with. So you have given now an assertion like picric acid is stronger than phenol. What is that? Picric acid. So what is picric acid? We will see. It is stronger than phenol. Phenol also we will see. Okay, then they are telling the reason as picric acid has minus COOH group, that is carboxylic acid group, while the phenol has OH group, that is the alcohol group. They are telling this is the reason. They are telling the picric acid is having carboxylic acid group, and because of that picric acid is a stronger acid than phenol. Now we need to analyze this question, sir. Very simple. Now we will see what is picric acid. I hope you could see. So if you see here, picric acid is nothing but you have phenol out there. So when you call something as phenol, whenever benzene ring is there, this is benzene ring, you can see here. And benzene ring is connected to OH group. This is called fundamentally phenol. Okay, this is a phenol. Now in this, if you are substituting nitro group at ortho, then para, then again at ortho position. So this constitution or this component, this particular type is called picric acid. So picric acid, how you can name it, sir? IUPAC, how you can name it? Number it 1, this is 2, this is 3, this is 3, this is 4, this is 5, this is 6, and this is 7. Sorry, this is 6, up to 6 it is there. So I can say this is 2, 4, 6 trinitro phenol. Correct? 2,4,6 trinitrophenol. That is nothing but our picric acid. Now how to analyze whether it is acidic or not? So I have given you earlier an idea how to check the acidic strength. Very simple. Check the hydrogen which is connected to electronegative element. Here hydrogen is connected to oxygen. So remove that. So while removing it, you will get something like this. Okay, I can say, okay, I will write it here for your understanding. Okay, so how to check the acidity? The thing is, first you need to draw the structure. Okay, so we have some shortcut out here. I will try to do that. Let's see. Yeah, we can do something like this. Okay, yeah, we will try to see. Okay. This is not there. One more minute, we will try it out. Just a minute. It's all try and error actually. So it should work actually. Okay. Now we need to do it. It is coming only here. Okay, let's see. We'll try it out. Then we don't need to draw, right? Yeah. Okay, it is not coming, I think. Okay, leave it out. We will draw it. Very simple, sir. So we will draw first phenol. Okay, so we have this the picric acid. So first thing you are expected to do here is what, sir? Very simple. So what you are expected to do here is, see here, you remove the hydrogen removed with the H plus removed with the associated with the electronegative element. So this will become what? O negative. And then you have nitro group out here, NO2. Okay, 3 nitro group is out here. Then we need to check once the H plus is removed. Once the H plus is removed, the remaining structure is stable or not. That is what we used to do. Okay. So here H plus is removed. So you are getting this as your anion. Okay. We know that here O minus can enter into resonance with the benzene ring. So already I can say resonance will stabilize this structure. And also the NO2 group that is connected here at a 3 point, this have minus I effect. So what does it mean? Through the sigma bond, the electrons will start flowing in this direction. Okay, electrons will flowing in this direction. So what will happen? I can say here charge density. I can say the charge density of oxygen decreases. So when charge density decreases, what will happen? Automatically I can say charge is inversely proportional to stability. So I can say stability increases. Okay, so charge density decreases, then stability increases. So I can say this one, once it leaves H plus, the remaining structure is highly stable. So this is a good acid. Picric acid is a good acid. Okay, and please understand, while you have seen the structure of picric acid, there is no COOH group here. So from this itself I can understand that the statement 2 is a wrong statement. They mentioned that picric acid has COOH group. That is wrong. It does not have COOH group. This is a wrong statement. From this itself I understood. Now I can say that here picric acid is a stronger acid than phenol. So now I need to compare with the phenol actually. Then only my analysis would be complete. So this is my phenol. Okay, so phenol I am drawing. So in phenol also I am removing the H plus from the oxygen to analyze the acidic strength. So the remaining structure what I am getting here. Is called phenoxide ion. This is called phenoxide ion. Now if you see here, this phenoxide ion is also a similar structure to this one. Only difference is there is no NO2 group. So I can say that here resonance is present. Okay, but there is no minus I effect of NO2 group that gives you extra stability. So I can say that this one is more stable than phenoxide ion. So this guy is more stable means, what is the meaning of that? If this is more stable means the corresponding acid would be a more stronger acid because it can leave the H plus and this would remain more stable here. Okay, so the first statement. Okay, 1 minute. Okay, there is some interruption that is happening. Don't worry. We will delete out. Yeah. We can open it again. Okay. Okay, I hope you could see now. Correct? Yeah. So from this we understood that the first structure is more stable than this second one, than the phenoxide ion. So the corresponding acid would be more stronger acid. Okay. Okay. So how we can summarize it, sir? So how to check the stability? How we can summarize it? So I can say that first thing what you need to do while doing the acidic strength comparison is remove, what you need to do, remove the H plus, okay, from electronegative element, from electronegative element. If more than one electronegative element is there, from the most electronegative element you can remove the H plus. That will be leaving out that H plus very fast. Then what is the next step, sir? Check for the stability of the remaining structure. Check for the stability of remaining structure. Okay. So while comparing two structures, the structure which is more stable, then the corresponding compound would be more strengthened, or corresponding compound would be more acidic. I hope it's clear for you. Okay. Now let's do out the next question. Listen. Here they have given the assertion like pyrrole is more basic than pyridine. They are telling basicity they are commenting about. Reason they are telling, in pyrrole nitrogen is sp3 hybridized. Okay. So let's analyze that. So what is pyrrole, sir? Pyrrole is nothing but, you can see the structure. So this is our pyrrole fundamentally. You need to learn this compound because it is mentioned in the textbook also. Okay, it is present in the textbook NCERT. So pyrrole is nothing but, this is the structure. It's a, how many, you can see 1, 2, 3, 4, 5. Then you have the sixth, 1, 2, 3, 4, 5. You can see 5 corners are present, and it is a heteroatomic structure. Heteroatomic means you have carbon and nitrogen. More than one atoms are present at the corners. Now they are telling pyrrole, what they are telling, pyrrole is more basic than pyridine. So pyridine structure, if you see, the only difference is it has 6 corners, 1, 2, 3, 4, 5, and 6th corner is the nitrogen. Now they are telling pyrrole is more basic than pyridine. Is this a correct statement or not? How do you understand that? We can see in the pyrrole structure, you can see double bond, then single bond, then double bond, then single bond, then you have lone pair, again single bond. So there is a cyclic resonance is here actually. That means conjugation. Conjugation give rise to resonance. What is conjugation? Alternation of single bond with a double bond or lone pair or negative charge or positive charge. So what happens? This lone pair is not localized here. It keeps on moving from one location to the other. Okay, so because of that, I can say this pyrrole is less basic. Why? Because lone pair should be localized. If it is available at a fixed position, then it can easily attract the H plus. When you will say some compound is more basic, if that compound is capable of accepting the H plus very fast, or if it can donate the lone pair very easily. But here we can see the lone pair is in movement. It is to keep on moving actually. So I can say this lone pair, because of this lone pair involved in resonance, this is less basic. Pyrrole is less basic. But when you compare to pyridine, pyridine also have lone pair. Many students will ask, sir, here also nitrogen has lone pair. But here you can see double bond, single bond, double bond, single bond, then double bond, then single bond. Here already double bond is present near to. So this double bond is involved in resonance. There is no need for this lone pair to enter into resonance. So this lone pair here is available all the time. This is available all the time. That means anytime this can attract the H plus, and that means this lone pair will make this compound more basic. Okay. So here I have tried to show you how pyrrole is showing the resonance. You can see this is the first structure. In the next structure, what will happen? The lone pair will move towards the double bond and it forms a double bond here. You can see here. When double bond is formed, this carbon will have 5 valencies. There is a hydrogen also present. So when double bond is there, it will have 5 valencies. So it will move to here as a negative charge. So you can see here. And in the next step, this negative charge will move here as a double bond. Then this carbon will have 5 valency. So this will move out here as a negative charge. So in the next structure, this will come back here as a double bond. So when it comes here as a double bond, nitrogen will have 2, 4, 6, 8, 10 electrons. That is not possible. So this will come out here as a negative charge. So you can see negative charge. So like that you need to draw the structures, but all these structures are different. This structure is not same as this one. Usually whenever you have odd number of corners are there, when resonance happens, the negative charge will hit all the corners. So here you can see negative charge is coming in this corner. Here it is coming in this corner. Here it is coming in this. Here it is coming in this corner. In the last structure it is coming in this corner. Now you do a repeated movement. Here it comes here. Okay, double bond comes here. So here it moves out here as the lone pair. So that's how it comes. The final structure is coming. Almost these two are almost same. Okay, so this you need not draw. So I can say 1, 2, 3, 4, 5 structures are available. Okay, 5 structures are available for pyrrole. Okay, so now tell me, sir, what would be the answer, sir? Pyrrole is more basic than pyridine. That's a wrong statement. I can say it's a false statement. In pyrrole, nitrogen atom is sp3 hybridized. In pyrrole, the nitrogen atom is sp3 hybridized. So if you see the pyrrole, we can see this is the structure and this lone pair is involved in resonance. So it is not available every time. So if it is available only, we need to consider that for hybridization. Otherwise, you can see 2, 4 and 6. Only these 3 pairs are available. When 3 pairs are available, sp2 hybridization. When 4 pairs are available, it is sp3. 3 pairs are available, it is sp2. 2 pairs are available, it is sp hybridization. Okay. So that is also wrong. So both are wrong statement. So assertion and reason are false means the answer should be which one, sir? Answer should be option 4 should be the correct answer. Okay. I hope it is clear for you. Okay, let's switch to the next question. Okay, it is also related to pyrrole. So pyrrole text it's mentioned. So this type of questions are very important. Okay, so again for students, those I am telling it again. So those students who feel like, sir, we are in the last moment of our revision, sir, we need more support. Feel free to contact us. We are Brainiacs Classes. You can come even for a single chapter. We are doing a thorough revision with exams and everything that is required for our students to get very good marks. Okay. So it will surely help you. And Brainiacs Classes, it started way back 6 years before, and it is one of the best institute, NEET institute that is available in Coimbatore. Okay, let's see. So assertion: pyrrole is a weaker base than its hydrogenated product. Pyrrolidine. That's what it is saying actually. But I can clearly say this pyrrolid here, there is a little bit correction we need to make it in the question. The hydrolid, it's not a hydrogenated product actually. Here, 1 minute, we can see like that. Here we need to here we need to understand one thing. Here pyrrolidine is fundamentally it is not a hydrogenated product of pyrrole actually. So this is a wrong question actually. I want to tell this is a wrong question, and we will do this later. We need to do some correction. Okay, so it's not a hydrogenated product. Okay, it's not a hydrogenated product. Pyrrole is a weaker base than its hydrogenated product. So they are telling it's hydrogenated product. That statement, hydrogenated product itself, is wrong actually. So we need to take the correct question and do it. Okay. So let's switch to the next question. Okay. Yeah. Let's see it. The carbocation CF3CH2 plus is less stable than CF3 plus. This is the question mentioned. Okay, assertion is this one: the carbocation CF3CH2 plus is less stable than CF3 plus. Okay, then the reason they are telling is, listen, In case of CF3CH2 plus, the strongly electron withdrawing CF3 group intensifies the positive charge, but in case of CF3 plus, the lone pairs of electrons on each of the three fluorine atom overlap with the empty p orbitals of the carbocation carbon, thereby dispersing the positive charge. So in this question they are talking about the back bonding that happens with the CF3. So we'll see this in detail. You can see this is the first option. This is CH2 plus and this is a carbocation. Near to it you can see CF3 is connected. Okay, and we can see this fluorine atom, 3 fluorine atom that is connected here. Okay, all these have a high amount of minus I effect. Okay, so what this will try to do, it will try the electron movement in this direction. Electrons will come in this direction, electrons will move in this direction. When electrons are flowing in this direction, the positive charge, the magnitude of the positive charge here keep on growing. So when the positive charge keep on growing, what will happen, sir? I can say the charge density keep on increasing. So I can say due to minus I effect of fluorine, electron shifted towards the fluorine atom, and charge density of the carbon atom, what will happen to it? It increases. So if charge increases, tell me, sir, charge is inversely proportional to stability. So if charge increases, then I can say stability of this carbocation, what it will happen? It will undergo decrease. So this stability decreases. Okay. Now what will happen to in the case of CF3? Many students will ask, sir, here also 3 fluorine atoms are there. They have minus I effect and electrons can flow in this direction. But please understand, here fluorine atom has a smaller size and carbon atom also has a similar size. So what will happen here is there is a concept called back bonding. There is a concept called back bonding. So when the size of the atoms are similar, and if the one of the atom have free lone pairs and the nearby atom has a vacant orbital available, this lone pair will enter into that vacant orbital. This phenomenon is called back bonding. And this is present in CF3 plus, and because of that this lone pairs coming here means this deficiency is removed and positive charge, what will happen to the positive charge? It decreases. So stability increases. Okay, stability increases. So I can say this structure is more stable, this structure is more stable. Okay, this structure would be more stable. So please look at the assertion. We can say the carbocation is less stable than CF3 plus. So assertion is a true statement. Why? Because carbocation is the carbocation CF3 CH2 plus, we can see it is less stable compared to this one, because this is stabilized by what? Back bonding. That is what explains as a reason. So I can say assertion and reason are true statement, and reason is a correct explanation for assertion. So option A would be my correct answer. Clear? I hope it's clear for you, all of the students. Any doubt you can ask me. Okay, feel free to put it in the comment box. Now let's go to some other questions. Here you can see. So here what they are asking here is, okay, this is the next type of question. Yeah, they are asking the correct representation of the hydraulic fission of CH3X is. This is what they are asking. Okay, so you can see here CH3X is this one. Okay, so its correct representation is asked. So how we can do this question, sir? Very simple. Now take out that question. CH3X is present. Okay, CH3X is present, and we know that this X here is a halogen. X is a halogen. We know that halogens are generally electron negative. So what will happen? The electrons present here will shift towards halogen atom like this, or we can say the electrons moves to here and the electron density would be like this. The denser would be near to halogen. Now what will happen? Now the bond strength is non-uniform like this. So when the bond is breaking, so what will happen? I can say this would become CH3 plus, because the electron shifted towards the halogen, and this would become X minus. This would become X minus. Correct? And please understand, this type of bond is called polar covalent bond. This is called polar covalent bond. Why it is called a polar covalent bond? Because polarity is developing here. In negative, delta negative, and here a delta positive is coming, because the electron is moving in this direction, electron is shifting in this direction. That will increase the charge density here, and it will becomes delta negative. Or we can say a dipole is developed here. A dipole is developed here. Okay, so what would be the answer, sir? So we know that it has shifted to here in this direction, and it becomes negative, and this becomes plus. Is that correct? No. So this is moving in this direction, means x should be negative. Yeah, this is negative. So I can say my correct answer would be option 3 would be my correct answer. Okay, I hope it is clear for you. Easy, right? Okay, yeah. Now next we have the next question, that is regarding the concept of electrophile. Okay, so we will try to do this question in the next class, and I'm winding up here today. So those who have not subscribed our channel, feel free to subscribe it. Okay, we will do continuous lectures, try to do it 1 hour daily from next week onwards. Okay, so please subscribe our channel. Those who failed to subscribe, please do it. And if you have any doubt in what I am explaining, please feel free to put it in the comment box. Okay, yeah, thank you.